was it?
847,700 x cubed y to the fifth 7 c to the seventh.
Okay.
That's what I got.
Yeah. So yeah, you can multiply it out. But if it's big enough, you don't have to. But if it's small enough, yeah, you should multiply it out. You're good. All right, good. Any question? Hey, you guys get the idea? Let me make it a little bit more interesting than this, okay? Because this is kind of, too simple. Okay, so let's because none of these you're not gonna have things factor for you, okay? So sorry. Okay, so okay, example 5 is kind of like the ones that you may see, like they don't factor the denominators for you. Guess what you have to do for this one? You gotta do it yourself. Go ahead, everybody try. I'll give you some. This time you have 3 fractions. Does that make any difference? No, you could have 10 fractions. It doesn't matter. It's the same exact rules. Okay, you use the same exact rules. Go ahead, everybody. Tell me, find the LCD. Okay, and this time, Cameron, you might want to multiply them out at the end. Yeah, yeah, that's fine. All right. So how do I do factor 3 for 5? Yeah, yeah, it's 5. It's prime already. What about 8? 2 to the third. You should know. Okay, and then 12. You get 2 times 6. 6 is 2 times 3, so you get 2 to the second times 3, right? So there you go. That's the hardest part, really. Second step, we write all the factors. Audrey, what do you write down? Yeah, 2 times 3 times 5. And which exponents did you choose? 2 to the third? Yeah. How many people got? I didn't write. Okay, so 5, 2, and 3 were used, and 2 to the third, right? Sorry. So what's that, guys? It's 8 times 3 times 5, which is? What is this?
480.
What? Okay, 120. Any question? Are you good? Right, we want to use LCD for these type of fractions, right? I mean, you could always find the common denominator, by multiplying 5 times 8 times 12, but we don't want to do that. Why not, guys? Can you imagine doing that? You could do it, but it's not as fast and not as easy, right? If you know the LCD, look, does 5 go into 120?
Yeah.
It better, because that's what this is supposed to do, right? How many times, by the way? Well, you could, look, yeah, it's easy, look. It's 5 times 8 times 3, right? So how many times is 5 going to 120? 8 times 3 times, right? What's 8 times 3? Yeah. How many times does 8 go into 120? Well, that's easy. 5 times 3, which is 15, right? How many times does 12 go into 120? Well, that's easy. It's 120, so it's 10 times, right? Any question? Does that make sense? Are we good? How many times does 5 go into 120? It's whatever 8 times 3 is. Because it's 5 times 8 times 3 gives you 120, right? What's 8 times 3? So it's 20. You could divide 16. Okay, here we go. Then let's move on to example. Let me give you something more interesting than this one. Okay. Here you go. This one looks a little bit different. See, we like something that's interesting. The other ones are kind of stuff we've seen before. But you know what? Even though they look different, it's the same exact steps that you do, okay, for all the other ones, okay? So try this one. 15 over 4k minus 6, 11 over 6k minus 9. We want to find the LCD. This time, instead of like some number or monomials, we have binomials, okay? So what are you going to do? Same thing. You're going to have to, what first? What do you have to do with the denominator? You must factor. Do we know how to factor these? Factor 3? Yeah. You should all know how to do this. Everybody try. You guys remember factoring these binomials? All right. So, How do we factor, guys? How do you do a factor tree or factor 4k minus 6? Is that even factorable? Yeah, you better know how to factor this. Aaron, how do I factor this?
You factor out 2.
Yeah, you have a common factor of 2, don't you?
Yes.
So 2 times what? 2 times 2k minus 3, right? John, what about 6k minus 9? How do I factor this?
3 times 2k
3 times 2k minus what?
3 squared.
3 squared? No, just 9. So you factor out a 3 from 9, what's left? Just 3, just 3. Isn't that what we get, guys? If you don't believe me, multiply it back, right? Okay. So we factor out our denominators, then step 1 is done. Step 2. Malia, tell me what to do. We have to write down all the factors, right? And yeah, 2k minus 3. That's it. That's your LCD. Let's make it a little bit more simpler. We don't write 2 times 3. Leave it like that. What do you, oh, by the way, how come I don't have to worry about the exponents for this one? They're all 1. They're all 1 exponents. So, and you don't normally leave it as 2 times 3. You just write 6, right? There you go. That's it. Your LCD is 6 times 2k minus 3. You don't need to multiply that. So when you have these, leave a factor. Okay, it's easier that way. Later, when we're adding and subtracting fractions, you will see why you want to leave a factor. You want to leave a factor. Okay, because it's easier that way. May I go to example 7? All right. Here, it's kind of like example 1, the one that we did in the very beginning. So let's do A and B. I got 15 over 2 times 2k minus 3. Can you complete? Fill in the blank. What goes up there? And then if I want the denominator to be 2 times 3 times 2k minus 3. And B says 12 over 3 times 2k minus 3. Now I want it to look like 2 times 3 times 2k minus 3 for the denominator there. So can you complete what goes in there? Go ahead, everybody try. What must go in? It's pretty straightforward, isn't it?
Yeah.
This easy? Okay, so for A, what do I do here then? Oh, you're still writing it down? I'll give you some time. Allie, what do I need for A? What's missing on the denominator? Look at this one right here. I have 2 times 2k minus 3 here. I got 2 times 3 times 2k minus 3. What do I need to multiply this fraction denominator so it looks like this? 3. I need 3. So can I just multiply the bottom by 3 of this fraction? No, you can't do that. If you're going to multiply the bottom of the fraction by, yeah, because 3 over 3 is really 1, right? So guess what people mess up on this one? Guess what people write here? Instead of, what should I write, by the way, on the top?
40.
Yeah, I should write 45. Guess what people write instead of 45? They write?
15 times 3.
They just, well, 15 times 3, yeah. Or they just write 3. They forget the 15. Can I forget about this 15?
No, this
No.
one.
Okay, so it's 45. So there you go. What about B? What do I need to multiply top and bottom of this by? How about, who haven't I called today? How about, I called you, Aaron.
Oh, Chancellor.
I called Chance. How about Chris? I mean, how about,
Chris.
huh? Harrison.
Yeah, okay.
Multiply by 2, top and bottom, sorry. I see. Harrison is right. 2 over 2. So should I write 2 on the top, or would that be right? No, you need to write 24. You can't forget about that original numerator, right? You can't. Okay. By the way, look what I did, guys. Look at these 2 fractions. Guess what? They both have common denominator. Okay. Turns out that's the LCD for those 2. So tomorrow, guess what we're going to do with these 2 fractions? You're going to be adding or subtracting them. Okay, that's it. Yeah, Judy, question? Oh, okay. So that's a good question. How do I know? Let's look at the first one. How do I know to multiply the fraction by 3 over 3? We didn't have this. We didn't have this. How did you know this? Oops. So how do we know this? Aaron?
On the right side of the equation, you see 3.
Yeah.
On the left side, you don't.
Yeah, here, look, you have 2 here, you have 2k minus 3. Well, what's missing? 3. So you just have to multiply the bottom one by 3. Whoops. Right, Judy? You gotta multiply the bottom one by 3 over 3. That's the only way to get, right? That's the only way to get the denominators to look like each other, right, Judy? And then here, you got 3, you got 3, you got 2k minus 3, 3k minus. What's missing? Well, 2 is missing, right? Any question? Are we good?
Yeah.
All right, let's look at the last example then. Are we ready? All right. Okay, here, this one is nice because it kind of combines everything that we've been doing, this whole examples, okay, from 1 through 7. It kind of combines them together. It says, look at the instruction. It says to rewrite each fractions with their LCD. Now, the other one, they just asked for the LCD. This time, they want you to rewrite them now, okay? So, first of all, in order to rewrite them with LCD, guess what we have to find first? The LCD. We don't know the LCDs yet. The first fraction is nice. Why? Because the denominator is already been factored. What about the second fraction? It's not factored, is it? The denominator. But do we know how to factor trinomials? Yeah, we better. Especially this one because your leading coefficient is 1, right? That's easy. Because all we're looking for is then 2 numbers. When you multiply, you get 4. When you add, you get 4. Okay. Is there such number? 2. That's right. Thomas, how does that one factor then? X squared plus 4.
X plus 2 times x.
Very good. X plus 2 times x minus 2. By the way, when that happens, we write x plus 2 squared. What is that trinomial then called? You guys remember? There's a special name for this trinomial. Yeah. Good. Perfect square trinomials. You guys remember that? Is every trinomial perfect square trinomial? No. Some of them are. Even though it factors, it's not perfect square trinomial, right? Unless you get the same 2 binomials like that. Okay. Anyway, so we factored the denominator. We've got to find the LCD. Who could tell me what to do here? Who haven't I called? I haven't called. Kristen. Can you tell me what to do? Yeah, very good. You write them all out. LCD is going to be x plus 2 times x plus 3. But we have x plus 2 squared, so you got to choose the square. Right? Isn't that right, guys? Right? Don't forget that square because you have to choose the highest exponent. Otherwise, right, the other one will not go in. So now that I have the LCD, how do I rewrite them with their LCD? Well, this is kind of like the example that we just did. It's like filling in the blank, right? We used to have x plus 2 times x plus 3 as my denominator. I want the denominator to look like this. X plus 2 squared times x plus 3. Judy, what do I need to multiply this fraction so that the denominator will look like this? Yeah, I'm missing x plus 2, right? Now, could I just multiply the denominator only? No, got to also multiply the x plus 2, right? Does that make sense? So what do I write up here? Do I just write x plus 2? No, then you get it wrong. It's 5 times x plus 2. Right, guys? You get the idea? Okay, do the other one then. What's missing? Everybody go ahead. Finish it up. We had negative 3 over x plus 2 squared. Now we wanted to have the LCD of x plus 2 squared times x plus 3. What do I need to multiply this fraction by? How about, who I haven't called Sophia. What do I need to multiply this? Yeah, multiply the top and bottom by x plus 3 is correct. Right? After all, that's really 1. Okay, so then we get negative 3 times x plus 3. Does that make sense? And guess what we're going to do tomorrow? After you do this, you're going to add or subtract. Now that you have a common denominator, you can add or subtract. Yeah. No, it's not. It's impossible if you don't have a common denominator. So in order to do this. Any questions? Guys, does this make sense? All right. No questions? All of it? X plus 3, yes. Because, you have to have x plus 3, right, on the denominator.